Hi guys, welcome to a new free tutorial by Nyjo about LiquiGen. We are still working with the alpha version. This one is the 0.3.1, so it's the latest one released by JangFX. In the past we posted something about the chocolate bar. I'd like to show you what we prepared last time, and it was just a rendered preview. You see we have something that is obviously not visible, it's a collider, and then we have some fluids that are going down and simulating something similar to a chocolate. It is still not perfect because, there are some features needed to work on LiquiGen to have something more precise, but we can use some tricks to simulate something like that. So first of all, we are using this setup that is part of something more complex. We are preparing to release a really nice LiquiGen cursor when LiquiGen will be out on the market. So for the moment, I'd like to show you something about how you can achieve something like that with using some tricks. So there are many ways to have the same result, but we are going to see how we can achieve it in a simple way, playing with a parameter setup. So first of all, let's go to use an HDR map just to have a better quality inside the viewport, and I'm going to use something I just downloaded from HDR website. It is completely free. You can download whatever else. And about the ground, we go to have a uniform color. Sorry, and we go to have maybe 0.5 for the brightness, just for the moment. So let's go to imagine what we can do with this one. First of all, for sure, this fluid is not working because you see that if we go to play, obviously we are talking about a splashy fluid, and also the material is not right. So first of all, let's go here, and in liquid appearance, we can tweak something. Let's say that we don't like to have the refractive, so you see that we have just a color. And then we go to have something that is more similar to the brown color we can have, for example, for a chocolate bar. Let's say maybe something like that. And then we can tweak more the reflectivity, but before I like to go on the ground and say that this one is darker. Okay, something like that. Then we can go back again to the simulation in the liquid appearance, and if we play with the roughness, you see that we have a higher roughness over the reflection, so the reflection are more blurry, and in this way we are going to achieve something that is more similar to a chocolate. Maybe we can remove a little bit of red color so it's, you see, more brownie. Okay, let's go to save this one, and I say chocolate 3.2.0.1. Okay, about the ground, we had the reflective ground. Let's say that it is more roughness, so that's really rough, and the color is dark, so that's okay. So the main problem is the splashy effects. By the way, let's go to have a smaller chocolate emitter, let's say 0.5 R, and then you see that that's what we have. It is still really splashy. By the way, the first thing we have to do is to animate the emitter. So let's say that that's okay to have this position, maybe something like that, and then we go here. Remember that we are going minimum at 60 frames per second, so if we go here, we are talking about 2 seconds to go, for example, in this place, and then we go on the other side again, and maybe we can also move on the side, and then we go here, and let's say that we go on the side of the view, and then we go here, and let's say that we have this one. So you see, that's the animation we have. It's simple enough. By the way, if we go to simulate, you see that's what we have. It is really splashy. It's not the right one. So we have to tweak some stuff. First of all, inside the emitter, we don't need the lifetime because the particles needs to live forever. So let's remove. Actually, in this way, it will be a problem because if you see the particles are moving and moving, and we'll need a lot of voxel and a lot of particles to simulate everything. So the problem is related to the particles that are going away. You can do something using the drains. So if you set a drain outside of this collider, obviously it will work. By the way, it's not a problem because we are not going to simulate a fluid that is moving so fast and so much. So don't worry about the drains. So we have the collider. That's okay. You have to imagine that the collider is obviously it's a different shape. So here we are using, you see, something like that. You can imagine that this one is a bar. You can imagine that this time we are going to use something different. So it's the same thing, okay? If you like, obviously you can say that the collider is not visible. So you're going to achieve the same result. Just a simulation. By the way, this one is a fluid, okay? It's something that is more similar to water. So what we can do to have something that is behaving in a different way? First of all, we need more particles. To have more particles, we can start having a flow rate that is higher. Let's say, for example, 5. You see that it's going to add more particles here, so it is starting to be more interesting. By the way, another things, we are using a really a setup that is really similar to a flip fluid, so it is splashy. If you like to have less splashy result, you have to go inside simulation, and you have to take care about the peak flip ratio. Now we have 95%, so it's let's say that it's similar to a completely flip fluid. If we go to 0, obviously we have a peak fluid, and in this way we're going to have something that is less splashy. It is going to create still some splash effects because we have no parameters that are controlling the fluid, so we have to take care about it to avoid this kind of behavior. So what we can do, first of all, let's play with the thickness. The thickness gives us the possibility to have the fluid that is sticking over the collider. Let's say 100%. And we go to see, and you see that now it is starting to behave in a better way because it is sticking over the surface we have. You see? Okay. By the way, we have to take care about it in a different way. So the sticking is okay. We can maintain this density, or if you like, you can have an higher density because this one is the density of the water. So if you like, you can have an higher density. By the way, it is not going to change so much what we are doing at the moment. By the way, you see we are going to have a higher density, and maybe it is helping a little bit the result. Here you can play as you prefer. You can have a higher density. By the way, you will see that going up and up will give you less and less result later. So don't worry so much about it. I like to have a higher tension between the particles because, you know, this one is a fluid that has a really high density. Let's say, for example, that we go for 720, so 100 times higher tension. And this one too is helping us to have something that is behaving in a better way. Okay? By the way, we have more stuff that needs some tricks. For example, the meshing. So let's go inside meshing. We say that we like to generate the SDF over the smoothing, and we go to a really high smoothing. You see, so we are trying to remove the particles that are visible. And if you like, you can have also a higher ISO value for the voxels, so you see that the fluid is behaving like a more, high tension fluid, more dense fluid. If we go to simulate again, you see that it's going to be more similar to what we are trying to achieve. Nice. So how we can play to have a better result? Something more that needs to be tweaked when you have something like that, so a fluid that is highly sticking over the surface, that you like to have, a more dense effects and stuff like that with a very high viscosity. You can simulate something like that, going, for example, inside the simulation and say that you need a higher speed, a higher substeps. So let's go, for example, to 4, apply and reset. Then we go to simulate. It is a little bit slower to simulate, but you see that now it is behaving more and more like chocolate fluid. You see? Okay, Control S. Let's go to see what we have. We don't need to see the shape, the liquid mesh. I like to see the points. We have still, I think, too low amount of particles. So let's go on the emitter, and we can say, for example, to use, let's say, 30. So we'll have a huge improvements about how many particles we are going to simulate. So let's go back to see the fluid, and you see that the simulation mesh is more precise than before. This one is looking really nice. Okay, we are moving step by step to something that is better than the previous test we had. Obviously, you can remember that you have always the possibility to use the path tracer to see what are you doing. Obviously, the material maybe needs a little bit of love if you are going to use the path tracer. So maybe the roughness needs to be lower. You see, to have a better specularity. By the way, let's go back to having no path tracer. Let's go back to having a really high roughness, and then when we are going to render, we can use the higher parameters for low roughness, using the path tracer to have a better quality. So in this case, for example, I have to say that I should go for, my idea is to go for a higher step, but we can also go to a smaller voxel to have something that is more precise. So the quality of the simulation will be higher and higher. We can still go lower. Let's try 0.075. In this way, you are going to have more details over the fluid. So you see that we have a lot of sub movement and details, and that's nice. The fluid mesh can be moved outside of LiquiGen to have maybe some treatment. to make it more stable. By the way, you see that it is working in a really nice way. You see that here we have the fluid that is moving down step by step. Usually I go to have an higher substeps. By the way, I saw that with the latest alpha, it is a little bit less stable when you're going to use an high substeps with this kind of setup. So we can make a test, but it's possible that it is going to crash. By the way, let's try. With a higher substeps, obviously you're going to have something that is more and more precise, so the effects to have a chocolate simulation will be higher, you know. So if it's possible, I will try to have it so we are going to have a nicer simulation at the end. We can have back the collider, so you see how it is looking, and we can tweak the collider to have something that is maybe darker, and let's go to have a higher roughness. Okay. By the way, I think it is going to be a nice simulation in this way, and you can have again more particles, but you see that at this distance that's really not bad. The thickness is really high. We see that it's still falling a little bit over the surface, so I think we are going to achieve something that is nice. Okay. Something more that we can do to have a better simulation. We can add, for example, some forces. The idea is that we can try to have, for example, let's say a kind of drag over the surface. So we are trying to add something to the simulation to have an higher dragging over the surface. Maybe it's not completely physically accurate, but we can do it. And something more we can do is, let's say this one is the frame 520. I like to do something. And I like to do a snipping. So let's see the simulation at frame. This one is the frame 520. So we'll try to simulate using another option. Inside the simulation, you see that we have the compensate compression that is set to 100%. And the compensate decompression of the fluid. Let's try to simulate with 100% compensation over the compression, the decompression of the fluid. And let's try to see what's going on. I'm going to save, and then we'll try to simulate until the frame 520. By the way, I like to show you during the simulation so you can see what happened. And we can also remove for a moment the collider to see how the fluid is behaving. You see that it is helping to have this kind of effects where we have less decompression of the fluid, so the surface is more like something that is really dense, like the chocolate. Okay, so this one is something more that is going to help us to have a better quality. I have to say that it's still stable, so I think it's not a problem. Maybe we have to touch a little bit the surface. We're going to make a test. By the way, remember that the surface can be exported outside and you can play to have a smoother result. By the way, you see that, okay, we can stop it. Let's double check how it is behaving in a different way. You see that it's different because it is trying to not decompress. Maybe we can do something that is in the middle between this one that has 0 and this one that has 100%. First of all, we can also double check if we can do something, you see, about the fluid bath with this high value for the decompression. We are having this kind of artifacts here, so it needs some love outside of LiquiGen, or maybe we can try to have a lower value, something like, for example, 50%. So let's try to simulate again, and we'll see the result in a few seconds. Okay, it is still behaving in a nice way, but I have to say that maybe it's still too much. So maybe a lower decompression compensation, like 25%, should be enough. And something more that can be tested is to have an higher substeps and see if it is still able to be stable, and we have still something that is high quality about the simulation. And I like to see if we are going to compensate the effects we had over the mesh. Now it is time, we can leave the simulation so we see the final result. Now it is time to play a little bit with something more, and I mean we can use additional drag forces to have something that's going to work in a better way to simulate an high viscosity effects. So let's wait to stay at frame 520. Let's say that that's okay. Maybe we go lower here. Okay. Then something I like to double check. It's testing just the initial frame here. And maybe we can do a test to see if we go to add a little bit of flip behaving, if it works in a better way. Okay, let's try maybe just a little bit, let's say 15%. It should be a little bit more splashy, you know. But just a little bit. So also on this side, you can decide if you like to have a little bit of splashy effects, or you like to remove it completely. It is up to you to decide how much it needs to be able to simulate something that is a little bit more like a flip fluid, to find, you know, the best result you like to have. By the way, we have a good and nice basic setup, so let's set to save. Okay, let's say that we go to add a force. Here we have a constant force, and the constant force is essentially simulating the gravity. If we go to create a new force, let's say a general drag, and we can rename this one as general drag, you will see that the fluid will have some kind of dragging, and it's possible to see also in the air. You see that it's dragging in the air, so it's going to slow down the falling down and also the forces about the movement. I have to say that this one is going to help. By the way, we can try using a lower substeps just to be faster during the simulation. So you see that it's helping on the side, but it is going to create some kind of problem because it is moving too much slowly. So I'm expecting to have something a little bit different. So the dragging can be helpful, but I have to say that for sure it needs to be lower, you know. So we can decide to have something like, let's say, maybe 0.3. So we'll have a little bit of drag over the air, we'll have a little bit of drag falling down, and then we have obviously a general drag over the force. Okay, let's say that we go to add something more, and I'm talking about, we can do something like having another drag. And this one is, let's call it a collider drag. So we're going to use the collider as the shape for the dragging. You know, let's say that this one is really high, so let's say maybe 10. We go to have something like a little bit of mask fall off distance and just a little bit of fall off, and we go to have also a little bit of dilatation to have this force that is behaving more. Let's remove the drag for a moment. So we have not the general drag, but then we have a drag that is working using just the shape over the collider. So we have an additional force that is dragging the particles, you know. Also this one can be tweaked and played as you prefer. And that's another nice addition. If you have, obviously now it is colliding with the ground, if you have a plane here, you can add a dragging also over the plane. By the way, let's stop, Ctrl S to save. Okay, if we go to check again the path tracer, you see that the result is really nice liquid appearance. Let's go back to something that has a nicer roughness. If you have a faster GPU, you will have something that is working better in a really fast way. Actually, here I'm working on an RTX 3090, so it's a nice GPU, but it's not so fast at the moment. You can use something that is faster. Let's remove again the path tracer and let's go back to an IE roughness and Ctrl S. We can have back also the other drag, and we can go back here and say that we like to have 10 substeps and apply and Ctrl S, and maybe just making a test to have a little bit more particles emission to something like 40. It will be useful to have something that is nicer. Like, let's make a test to see how this is looking. I think that the general drag is still too high. Let's say maybe 0.1. So it's lower. And I think that our simulation is really nice at the moment. So if you like to have something that is complex, like we done in the preview video, let's go back to F4. Okay, you can have two emitters. I'm going to duplicate both. So let's say that this one is the first one, this one is the second one, and we are going to emit both. And this one will stay in another position, so we'll try to trick it, because now obviously it's behaving in the same way. So we can say that this one is here, and let's see what happens. Okay, let's go here, and we say that we go, sorry. We go also, you know, to tweak the position. In a different way, you know. Let's make this one maybe 18, and then here okay, let's see what's going on. It is obviously doing different things. So in this way it's going to make something that is similar to the preview video you saw before. We have also the fluid that is going one inside the other one, so Ctrl S just to be sure that we are not losing anything. By the way, I think that that's a simple but nice setup to play with something similar to a chocolate fluid. Okay, and you see, for example, now we have the maximum amount of particles because we have 5 million particles. We are still okay with the mesh and also the voxels, so we have just to take care about the particles. You have to go here and check how many particles we have. 5 million particles, so let's say to have around 25 millions, and let's keep more space for triangles, and then we can simulate this one. It is still to 4, let's say 10, apply, and then going to prepare a nice simulation, and we'll see the result in Path Tracer in a few. Okay, so to make this one, if you like, you can also render the stuff if you like, but in our case we are just going to see in real time what's going on. So it is useful to see together how the simulation is behaving, just to have a rough idea about what you can do with this setup. Remember that you can go out exporting the mesh. For example, an idea is to move the stuff inside, let's say Houdini, then you can convert the mesh to, you can play over the polygons, but if you like you can convert to VDB, and then you can play with the various nodes. You have to tweak the VDB volumes, and then you can go back to the mesh as a polygon. Okay, so there are many ways. Something that can be done is, let's do it, so you have a setup that will finish to simulate. Let's say that at 64 it is going to have no more emission. So emitter activity is animated, and this one too is animated. Let's go at frame 640, and we say that this one is no more working. If we go at the beginning, we say that at 0 it is active, and this one is active too, and Ctrl S. So in this way the particles will be emitted just until the frame 64. Again, just to speed up the stuff, no, let's see the real quality. The way I like to, so that's the camera. Let's say that the camera is 70-20, and we go to have something that is similar to the stuff we've done, but I like to see how it looks, so we need something fast. Okay, it is crashing, sorry. So let's go back to 4 and simulate, because obviously the parameters we are using to simulate the chocolate behavior needs a nice substeps, as I said you before. So I'm trying to find a nice position to see the simulation. Okay, maybe this one is enough. Okay, stop. We go back to 10, apply, Ctrl S, and then we say to export the render. That's okay to use the camera 01. It is going to export everything to a sequence. Let's say 70-20, and we say until frame 700, and then I go to export here. Let's call it chocolate is just a temp render, so we don't care so much about the naming. And then about this one, we go just to add an underscore and then the frame number. Okay, so that's what we are going to achieve. Let's say that we go to export the rendering. It will take a little bit, it is not so much. By the way, we'll see the result together in a few. Okay, render is done. Please remember that when you go to launch the render, to use the same setup we had in the viewport, we have to set this one not as rasterizer but with render viewport. If you like to use the other one, you have to set everything. If we go to see the simulation, that's what we have. And that's really not bad. Okay, so let's go back in the scene, and we have the right sub-steps. We have this setup here. Something additional I like to remember is that if you like to play a little bit with the tweaks you have, you can imagine to have again a lower compensation for the compression. It is something you can do, or you can play with the sub-steps. You can play a little bit with the tension and density, and if you like, you can add more forces and stuff like that. By the way, that's something that can be a nice initial setup for you. So you see that it works in a nice way. It is really not bad. So I think it is something you can use, and you can play with to achieve something that is more interesting, or maybe more similar to what you are trying to achieve, you know. So it is up to you to decide how it needs to be tweaked. Maybe we can have a lower roughness here, and also about the look, you can play with the look as you prefer, you know. So don't worry about it. It is a nice way to play with our setup. And let's go back to this one. Okay, and now it works. So guys, that's all. I think you can play with this setup in a really nice way. So take care about your setup. If you have any requests or suggestion, please contact us without any problem. And then we are trying to prepare some more nice tutorial about LiquiGen in coming weeks and months. And as I said to you at the beginning, we are starting to prepare a really nice cursor that will be available when LiquiGen will be available. Okay, so thanks for watching, guys. See you soon. Bye.